We'll just give it a minute to get everybody in the door here. And great to see so many familiar faces to all of us here in Baltimore. And we'll get a chance to get to know each other during this webinar. All right, so I'm going to go ahead and give a little bit of an intro and get us kicked off, and then turn it over to our panelists, which is going to be far more exciting than listening to me. But the overall project is called Evaluating Open Data Portal Technology for Smart Cities and Data Science Learning for Social Good. I want to thank my partner, Mike McGuire at Towson University. My name is Seema Iyer, and I oversee the Baltimore Neighborhood Indicators Alliance at the University of Baltimore. And this is a project funded by the South Big Data Hub. So thanks to them for supporting this work. Today's webinar, we're going to get into who our speakers are: Michael Zentner, Joseph Yun, Sandi Caldrone, and Ale Strachan. But let me tell you a little bit about why we're even doing this. Like I said, I oversee a project called the Baltimore Neighborhood Indicators Alliance, and we are the Baltimore partner of a network, a learning network of other cities that are trying to put out data for communities to better understand how neighborhoods change over time. It's we're the National Neighborhood Indicators Partnership. Now, Baltimore was the 6th member back in 1999, 2000. So we've been doing this for a while. And now there are more than 30 cities nationwide. So you'll see some of our partners in the room, the virtual room. So thanks to all of you that are from some of these other cities. So in your participant, you might want to say that you're an NNIP partner with us. You can also say if you're a part of the South Big Data Hub. We know we have other members of the South Big Data Hub here with us too. What we do here in Baltimore is put out what's called the Vital Signs Report. It's an annual compendium of a wide variety of data points for all of our neighborhoods. Comes from about 50 different sources of information. We put out over 100 indicators every year, and we ourselves operate an open data portal, which if you're in Baltimore, hopefully you're getting familiar with this. We're probably the first place in Baltimore to get any kind of open data way back, in the early 2000s. And now we actually operate our own open data portal. We did a seminar on our open data portal back in January, and we can put the link to that one, and all of the other webinars, we'll send you that link as we move along. So the project that we have been working on for the last year is actually called the Baltimore Data Science Core. And there are 4 institutions in the Baltimore region through an NSF grant for harnessing the data revolution. So University of Baltimore is one of them, Towson is another, UMBC, Baltimore County is a third, and then Bowie State is the 4th. And we are trying to create a way for students learning about data science to use their skills for good, for social good in cities like Baltimore. So that's the ultimate goal. And what we wanted to try and do is to create a way for the students to learn from each other based on work that they're doing. So here's the reason why we're doing this project. The what is that we're creating these series of webinars, and we're evaluating different types of open data portal technologies so that for the who, anybody who's thinking about setting up or hosting an open data portal, like some of you in the audience, you might think about which one to use for setting that up. And when I say open data, I don't just mean, data sets. I think what you're going to find today with the HUBZero, it's really about open knowledge in some ways, actually sharing and learning, and data might be one aspect of that. So creating a way for us to share what we know and what we are using to understand cities like a Baltimore. We want to try and allow our Baltimore Data Science Core to publish and host and develop things that other students can learn from and not have to start all over every time they want to try and learn something. And then eventually you'll see that all of these resources are available on our website, and we'll put that link for anybody that's in the room and then anybody that watches this later. So these are the questions that we pose to our panelists based on who we think the audience is. How can you set up a platform that has multiple publishers? And I mean publishers to open data, and again, thinking very broadly about what data actually is. What's the process for documenting so that other people can understand what's on the portal? How can you update? How do you customize? How do you integrate visualizations? And issues that you might think of as a manager for maintenance and cost. So these are the broad themes that we suggested to our panelists to look at. And now I'm going to introduce you to our panelists. We're going to start off with Michael Zentner, who is the director of the Sustainable Scientific Software at San Diego's Supercomputer Center. Thanks so much, Michael Zentner, for being here. He's going to give a broad overview of what HUBZero even is. Then we have Joseph Yun from University of Illinois, Urbana-Champaign. He's going to be talking about the project that he's working on there. And then Sandi, Caldrone, and Strachan from Purdue University talking about basically case studies of using HUBZero as a platform to disseminate information. So I'm going to stop there. Each one of our panelists are going to give about 15 minutes. And then at the end, Michael McGuire from Towson University is going to moderate a Q&A with all of your questions. So feel free to put questions in the chat. All of our panelists will be reviewing those chat questions, and we're happy to have this be as interactive in the chat as you want. So I'm going to turn it over to Michael. Thanks so much for all of you for being here.
Okay, thank you, Seema. I'm going to do the screen sharing thing here again. And all right, is presentation visible and everybody seeing it?
Yep, we're good.
Good. Okay. So yeah, as Seema said, the flavor of the talk that we give today might be a little different than a couple you've had in the past because of the platform does quite a few different things. And rather than go through this extensive title, I'll start off with a question for you. What do you think the study of volcano science, human-animal bonding, nanoparticles, climate change, medical informatics, material science and manufacture, plant biology, social media, pharmaceutical manufacture, the search for exoplanets, data repositories, intercultural learning all have in common? Not a lot, you might think, but one thing they do have in common is these are all different kinds of science communities that the HUBZero platform supports. And in fact, we in the HUBZero group operate about 20 to 25 different hubs for a lot of these different communities, but it's also an open source platform that's out there doing a bunch of different things for on the order of 60 different hubs. I think that one thing we can say about research is that it generates data and it generates information amongst a lot of other things. And sometimes I guess I'd say information may be derived from data. So what you might be expecting me to talk about today is something like the following. HUBZero as a quote data site where data creators may be supplying data to some sort of site, which is then responsible for wide dissemination to a large size audience, of all different kinds of people. That's not exactly how HUBZero is positioned. Rather than that, HUBZero is more of a mediating platform or a sharing platform. And data may be part of a HUBZero platform, but it may be sitting elsewhere, and HUBZero may be acting as a mediator for those data. And it does work between data creators and audiences that would consume those data. But I want to modify the notion of data creators here to also include software creators. We actually view software, as many do, as a form of data. It's just a different kind of form of data that's also executable. And I further want to add to the thing that says data science a couple of other things. We also connect to expensive resources such as supercomputers that process data for a variety of purposes. And we connect to expensive instruments that generate large volumes of data as well. So the kind of problem area that HUBZero is focused on is answering this question mark. How do we connect software and data authors with big resources, with large audiences who may want to use both of those things in ways that neither of the original creators might have intended to be used? And so that is a solution, if you're not familiar with the term, called a science gateway. And it does do these top 3 things, but it also does a lot of other things too. And some of those are listed below. Certainly we see a lot of people using these gateways for interaction and collaboration, reproducibility of results. You hear a little bit of that from Ali today. Running citizen science projects even, and publishing results, of course, and a lot of other things. So how I like to describe HUBZero is in 3 main functional areas. Community interaction and collaboration facilities, other facilities for making knowledge and publications available to the community and keeping track of those. And then the third is a large collection of middleware that allows all of this different kind of resource sharing with data and instruments and big computers. This stack, as I've already said, has been used to operate a wide variety of hubs. Here's a few more that I didn't show at the beginning. And these are run all across the US. It's at many different institutions. And what I'd say about each one of these is that HUBZero as a platform, when you implement it, takes on its own personality depending on the needs of the community, right? So the dark purple wedges here are meant to indicate that any given hub may not use all of the capabilities available in the platform, may just use a subset or some combination of subsets. And occasionally this stray purple thing going out to the side, occasionally we get asked to help customize something that may not be part of the platform coming out of the box. Another way for people who are outside of the HUBZero community or developer community to think about these are these gateways. HUBZero gateways are basically a way of accessing cyber infrastructure, generally for people who don't know and don't want to know about cyber infrastructure. So that's one aspect of it, is increasing accessibility. A second is that I like to think of them as broader impact engines for those who do know about cyber infrastructure and the ways that it can propagate their data, computation, and research results. And I think you'll see examples of all of those things here today. In terms of how do you run one of these things, or what does it take to run one of these things, it takes a pretty wide collection of technical expertise. Certainly some domain scientists, but all of the other skills you see here, cybersecurity, middleware, web design, certainly database, and everything else you see on this side. But it's not just that. To really run in production mode, you need to have the business side addressed too. And that's certainly on the management perspective, running outreach, a lot of administrative things, and even selling. As projects seek to become sustainable, they've got to learn how to sell themselves. And so we support these functions. All in all, this is about 20 full-time professionals supported by yet another 10 full-time professionals at SDSC that do this kind of work. And we make these people available in the slices that projects need. So a lot of times you either wouldn't have the budget or wouldn't even be able to find people with all of the skill sets you see listed on this list. And our goal, by leveraging across many different projects, is to make those people available in the slices that projects need without them having to make full-time staff decisions based on that. HUBZero has been a project that's been around in one form or another for quite a long time now. NanoHub was actually the founder of HUBZero back in 1998, when the idea of putting simulations in the cloud was something quite new. Maybe it isn't as new today, but back then it certainly was. It was funded in 2002 as the Network for Computational Nanotechnology by NSF. And it's grown today to about 2 million unique visitors a year. So this is a very successful science gateway. Now, around 2007, one of the people on the advisory board suggested to the NanoHub team that this thing that they use to run their science gateway ideally should be able to run other science domains as well. And so at that point, HUBZero was spun out as a separate organization at Purdue University. And then 2 years ago, we moved that organization and a lot of its personnel to SDSC. So that's where we sit today. How do people work with something like HUBZero? There's 3 primary modes in which people can work with it. Our team does participate as subcontractors or sub-awardees on sponsored research projects when some intellectual contribution from a cyber infrastructure side is needed, or new capabilities that aren't part of the core HUBZero platform are needed. And so we do this. Many times for people who don't have the resources to run a production Science Gateway 24/7, we provide what we call a no hassle service. And the idea here is to allow the scientists to focus on the science and for us to take away a lot of the IT hassles that go along with upgrades and security monitoring and patching and all that kind of stuff that you want to do to make sure that your data remain secure and backed up and all that kind of good stuff. However, it is also an open source platform, and we do have people that download and run the open source and can modify the code themselves. About all I would say about that is it's not an endeavor for the faint of heart. It does take effort to do this. It's not something that you can generally succeed at by asking a grad student to do it in their spare time. So we really do believe the way we offer this way of working in a no hassle way is actually pretty economical in comparison to trying to hire your own staff. But if you think you have all of that staff available, you can do this as an open source activity. And so rather than give you a full demo of HUBZero today, which I think you'll see some of from the other folks on the call, what I thought I'd do is just give a quick take on what some of those people are doing with HUBZero. So when you hear about social media macroscope, I like to say it's connected to the largest instrument on the planet. And you might think, what does that have to do with the Large Hadron Collider? Nothing. The social media instrument is generating immense amount of data every second. And this is the work that Joe Yun will tell you a little bit about. At Purdue University Research Repository that Sandi will talk about, this is managing research data for a very broad university research portfolio and making sure those data don't get lost and are part of data preservation plans and so on. And NanoHub, the original founder, Ali Strachan, is going to talk about that. And what's interesting about this data repository is it takes 2 forms. As people are running simulations, they're actually passively creating a huge repository of simulation data results. And these can be used in a variety of different ways that I think Ali will tell you about today. And also actively collected data in the forms of these software suites that people post for other people to use on the gateway. And there's over 700 of those software applications now. So what you're going to see today is really a blend of computation and data management and data repository that might be a little bit different than some of the other presentations and platforms that you've looked at. If you have questions after the presentation that we don't get to in the discussion time, you can always contact info@hubzero.org and somebody will get back to you with answers. But with that, I think I'll end my discussion and turn it over to the next panelist, unless Seema, there's a different moderation scheme going on here.
No, that's perfect. Thank you, Michael. And we'll have questions from the audience towards the end, and I will turn it over to Joseph. But the one thing that I took it over was the number of staff and thinking about producing open results at the beginning of your project, and actually thinking about having you guys on board during the grant writing process, which is really an interesting way to think about it. Joseph, I'm going to turn it over. We're heading, I think you were in San Diego, right, Michael? And now we're heading to Urbana-Champaign in Illinois.
All right. Thanks so much, Seema and Mike. I'd like to share with you all a little bit about the story of the social media macroscope, and I'll keep looking at my phone to make sure I don't go over time. So the journey started when I was in my PhD program, and I did my PhD at the University of Illinois here. And if you know about our campus, it's kind of split north-south. So north is all of engineering, and then south is like everybody else. And so, you know, I did a interdisciplinary degree. So half of my degree was, or my committee was computer scientists, and then the other half of my committee were social scientists. So when I would be on the south side of campus, a very common conversation that I'd be having with a social scientist would be something like this. You know, I have this research question I'm trying to solve. I want to use social media because of the social phenomenon that's occurring. And I want to use social media to solve my research question, but I think it'll take many years and much difficulty to create an algorithm that detects this kind of psychology. And then I would say, oh, you know, actually there's a researcher right here on our campus, literally across the street, that has created an algorithm for that. And the social scientists would, you know, be super excited. They'd be like, okay, how do I use that? And then my answer would be, okay, all you need to do is read their CS conference paper, go to their GitHub, take their unfinished code, branch it, edit it, et cetera, and of course, either the conversation would go to, Joe, can you do that for me? Or, you know, I'll talk to you later, right? And so that would be a conversation I had all the time during my PhD. And sometimes I would help if I had the time, and sometimes I couldn't because I was working on my dissertation. And then I'd be on the other side, maybe even meeting with one of my committee members on the north side, and they would say, you know, we have this awesome machine learning algorithm that detects such and such from social media data. It's got X accuracy, F1 scores Y, and we've won Z competition. And I'd be excited with them. It's amazing. And I'd say, okay, well, how do you know that your algorithm, let's say, that detects some kind of social phenomenon in social media, maybe misinformation, how do you know that it's good enough to be now used or applied to answering you know, real life research questions? Because I'm positive if you can figure out how good it is, or if it's good enough to like test in real social settings, that, you know, this could be really helpful for the social science community. And so they would say, oh yeah, like I really want to see if we can figure out if it's ready. Let's get this tested. Let's engage social scientists. And then I would say, okay, well then how about you take your code, you know, harden it a little bit, document it, put it up on the web with a GUI interface, because, you know, many still don't program, and so give it some kind of UX design that a non-programmer could use, and I think we could really test it. And then, you know, again, for them, that's not what they're necessarily focused on, right? With the academic structure of things, right? It's publish a paper, put some code out, move on, right? And so that conversation would kind of go nowhere. Well, I, you know, and I say this with all due respect, so I'm not saying anybody is, you know, in the wrong here. I'm just saying that I would hear this so much. So eventually I just started thinking, all right, like I want to just create something that kind of bridges this gap. And so started to conceptualize this concept here, which was, you know, the world is producing a bunch of social media data, and researchers want to research that data. So can we create some kind of instrument that's kind of like a microscope and a telescope, and we put that together and we called it the macroscope, to create the most advanced open. And that was important to us, to make everything open about it, open source. I'm open to questions. The most advanced open social data analytics platform for research in the world, and open even with regard to accessibility, to make it free. That was my that was and still is my goal. And so this was work that started during my PhD, and eventually some other people joined this crazy idea as a side project. This was not my dissertation, and this is still not my full-time job by any means. It's still a side project. And so basically now I can say that we've got about over 100 institutions around the world, you know, using it in various ways. And the social media macroscope basically helps researchers without primarily computational backgrounds. So researcher could be a very general term. Anybody that wants to analyze social media, we've, you know, piloted this with high schoolers to try to teach them data science in a fun way. But primarily without computational backgrounds, to analyze social media data by offering an open source social data analytics environment that does not require coding. And so that's a little bit about the background. This is what the front page looks like. This is hosted on HUBZero. You can find it at www.socialmediamacroscope.org. Now, I just want to make a comment about it. it's the social media macroscope itself is not a tool, because most people will say, yeah, I need to analyze it with the social media macroscope as if like that is a tool. I like to compare the social media macroscope as like the app store on your phone. So the app store on your phone is an app, but you don't go to that app to do anything but to look for other apps. Or I don't know what else you might do on it, but primarily we go to look for other apps. And so the social media macroscope is really just a place where we've contributed open source tools that you can run from the HUBZero environment. And we're hoping that more people out there will submit their tools that they can run from this macroscope HUBZero environment. So we have 2 tools right now that we created. We actually have 3, but one is private. We created it with the World Health Organization for COVID social media tracking. So the 2 tools that are public are SMILE, Social Media Intelligence and Learning Environment, and BAY, which is a brand analytics environment. My background is computational advertising, computational marketing. And so this is just a screenshot of if you open up SMILE in our environment, which again runs on HUBZero, it just pops up kind of automatically an instance of this code that allows you to walk through analyzing, collecting, first of all, social media data, then analyzing it, and then exporting it for publishing purposes. And I wanted to mention with this that social media analytics is not a new thing. It's not like these are revolutionary tools, because you can buy tools out there that'll do an even better job than what we do. But those tools that you buy are easily hundreds of thousands of dollars a year, if not more than that. And we're trying to create on par and sometimes better because of the accuracy of our algorithms, tools that are open in every way. So I did that in 7 minutes, and I wanted to just say something about our experience with regards to creating this platform, since I think many of you are thinking about creating a platform, a data platform. And I want to say again, like, this is not my job, and this is not in like any way my job. So this is a side gig that I'm constantly just trying to keep going and hoping someday that somebody with a lot of money will like take it up and make it a big thing. But until then, just like keep it going. I can say that we recently were contacted by members of Congress because of COVID misinformation to help them. And we actually are testifying at a congressional hearing regarding COVID misinformation. So it's getting recognized. We're going somewhere, but it's a hard side gig to keep going. When I feel like 2 full-time jobs and 3 kids. So HUBZero is key, and I don't work for HUBZero. I've never received money from them. In fact, I send money to them, and I'm not a salesperson for HUBZero, but I did want to identify some of the reasons why HUBZero is helpful for this side gig of mine and my team. So first, Mike mentioned it, but the fact that they provide the deployment and scaling environment, that's just huge for us, because I'm not an infrastructure person, and my degree is computer science, but like there's just so much that I both don't have the time for, and I don't have the knowledge to do. And so HUBZero has been incredibly helpful in that sense. Additionally, they host and maintain the environment, right? So when I say deployment and scaling environment, I mean, like, it's like really cool stuff where they can take your code and they can create basically, virtual instances of it and then just kind of present it in the web. I will say that we just Dockerized our code recently because one of my team members is really into Docker. But then we also have people from around in our community asking for a Dockerized version so they could run it on their local machines. And then HUBZero even told us, hey, like, we're starting to play around with Dockerization. Maybe we can take those Docker images and make it an even more efficient way of presenting the macroscope for people. But working with them to kind of think about that, and the fact that they do all the maintenance, all the security, all that stuff, it's super helpful. In fact, I don't even notice most of the maintenance unless they tell me they're doing maintenance. And so that's great. Another thing is that we have a direct contact that we work for. I mean, I'm not saying that it's like super cheap for HUBZero, no hassle, because if you're in academia, like anything above $10 is like expensive, right? But for what you get, it's super cost effective, especially because you have a person that you're talking with. Claire is my person that I speak with. And before her, I had an individual named Nate who was amazing. Both of them are amazing. And I just want to identify that, like, I'm not sending tickets to a help desk. I'm working with a person that exactly understands what's going on with my platform. This is one of the biggest ones. They are a nonprofit, and specifically an educational institution, which I work at a public university. Anything we try to buy, like over $10, goes through this procurement process where, like, I have to get bids for a sandwich, and that process will take like 6 months to, and it sounds like I am kind of joking, but I'm being really serious. And the fact that, they were first at Purdue and now at UCSD, we don't have to go through any of that process because, it's a governmental organization. And then another thing is, I mentioned this is my side gig. So for me to find money every year to continually fund this, I'm literally like begging people to believe in this and for money. And so when I can't find people for a little bit, the HUBZero team, will work with me to kind of extend my deployment until I can find the funds to keep it up and going. And so it really is like a partnership. I think they're a for-profit company in some way, but it doesn't necessarily feel like that with regards to the relationship that I've had with them. And again, I don't work for them, but it's been a great journey together. So with that said, I just wanted to give you a little bit about the macroscope, a little bit about our experiences with HUBZero. And if you have any questions, please contact me in the future, and I'd love to talk. So that's it for me.
Thank you so much, Joseph. And if anybody does have questions, you can put it in the chat now, or you can wait till we have our Q&A at the end. Feel free to do either one. And all of our speakers' bios are in the chat in case you haven't seen them. And so we're going from Urbana-Champaign to Purdue University, and we're going to start off with Sandi Caldrone. Thanks for being here.
Hi, thanks for having me. Let me share my screen. And while I'm doing that, I should also note that I am at Purdue right now, but in October, I'm going to be moving over to Urbana-Champaign with you, Joe. So maybe I'll see you around campus.
We welcome you.
Thanks. So I am going to talk a little bit about the Purdue University Research Repository. We're a very different kind of hub than the social media macroscope. So instead of focusing on kind of tools and data, we are rooted in the Purdue libraries, and we are focused on the publication, preservation, and dissemination of data sets that are created at Purdue University. And so we have been in operation at Purdue and on HUBZero for 10 years now. We often go by our acronym PUR for Purdue University Research Repository, and you can find us online at pur.purdue.edu. Over the years, we have worked with over 4,600 users. So those would be Purdue faculty members, staff members, students, and their collaborators, basically anybody in and around Purdue who is creating data through the course of their scholarship. Over those 10 years, we've published over 1,200 data sets, and those represent folks from 51 different departments across campus. And I mentioned that because that really drives a lot of our identity and our functionality, is that we are not trying to work with a particular kind of data or even a particular subject. We're trying to create a general service that could be used by anybody at Purdue, whether you're in the business school or the veterinary school or one of our many like engineering programs. So we have a kind of agnostic approach to data and science. We want to create a platform that can handle any type of file, any type of data. And that really drives us to have kind of a simple architecture that looks at data as files that can be transferred and then actually utilized on a different platform. So we're kind of the hub that disseminates the information, and then people take it elsewhere to actually manipulate it, analyze it, visualize it, that kind of thing. And so, you know, we publish data, that's kind of the heart of what we do. But surrounding that, we want to provide support for Purdue researchers throughout the research lifecycle. And we do all of this through our HUBZero website. And so we start with really the beginning, the genesis of the research project, the planning stage, or for many academics, the grant writing stage. So we have a small team of data scientists in the Purdue libraries that work on PER and will consult with folks as they are planning their research projects about general data management best practices, and will help people write data management plans for their grant proposals as needed. And of course, we're often counseling people to use PER in those data management practices, but not always. Our aim is really to provide support for every researcher on campus, whether or not they actually use PER's publication services. And so during the active research phase, before folks get to the publication phase, we provide a collaboration space online. So Purdue users can log in to our website and access private shareable file storage space. You can set up different projects for the different research topics you're working with, and invite different teams of collaborators to join you in those projects and share those files with you. And again, because we're trying to serve folks all over campus, it's a very agnostic process that's very simply structured. So we don't have a lot like tools for interacting with and editing with files in PER. We are kind of a storage and transfer system. Folks can upload their files, download them. And the niche that we really fill here on campus is, there are lots of file storage and sharing options, but our kind of the sweet spot that we occupy is a university-backed technology that people can trust, that they know is part of the libraries and not part of a corporation, and that has on-campus, on-call support if they have trouble using it. So that's an important feature as well. And since it is all mediated through our hub website, people can access it from anywhere, so they don't have to be on campus to access their data. They can easily share things with collaborators at other universities as well. And then when the research phase gets to the phase where you're actually publishing data, we publish data files that are totally web accessible. You are all welcome to go to our website now and download data files and reuse them yourselves. There's no kind of login or paywall or anything that those data sit behind. And that's very intentional because we, as part of the libraries, want to be able to disseminate the results of scholarly research as widely as possible. And that also meets important requirements for government funders and even journal publishers that want to see the data that they produce shared. And so in addition to making these data sets available and accessible online, we are also carefully kind of preserving and archiving them. We partner with the Meta Archive Network, which is kind of a member group where we all have various nodes across the nation and preserve copies of each other's data. So it's very safe and duplicated and secure for long-term preservation. And then also thinking in the long term, we're also tracking the use and impact of our published data sets. So we are, counting views and downloads. And then we also do some citation tracking where we try to keep track of who is citing and using our data set so that we can see that kind of web of science and connections bloom across disciplines. And so I'm mostly going to talk about our publications because that's really at the core of what we do. And I think that that will also just help illustrate some of the ways we use the hub and how we've kind of built some custom pieces on top of that normal functionality. So in PUR, we have 4 different types of data sets. By far the most popular type is files. So these would be any type of data files and supporting materials that PUR will bundle up with descriptive metadata and make available online for download. So you download those as a zipped bundle and open them up on your computer. We also have a database option, which instead of just providing a download link on our website to download the files, we can display them in an interactive table on PUR. We have a series option, which is kind of an umbrella record that ties together related data publications. And then we have some new custom functionality we've just built for registered data sets, which allows users to catalog their data in our collections and receive a DOI or digital object identifier without actually making their files available for download via PUR. They would instead provide a statement about how to request those data files or where else they can be accessed. And so we're hoping that will really open the door to data sets that are either too big or too sensitive to just allow for open access to downloadable files. And I'll show you just a quick example of what some of this looks like. So this is an example of a published data set on PUR. This is what most of our publications look like. This isn't the whole page, but it gives you a sense of what we have here. So we are collecting descriptive metadata from the authors. And so they're providing information that basically gets its own landing page in PUR with basic description like title, authors, author affiliation, and then data files that are available for download. And our database option looks something like this, where we have data in a structured table that you can interact with on the PUR website. This is great for those data sets that have a ton of small files and you want to show the relationships between them. This, for example, is an archaeological data set where we have hundreds, maybe thousands of pictures of broken bits of pottery. We can display the images from those image files and then put them in context with some information about those images and allow users to kind of filter and rearrange as needed for their purposes to actually interact with that data on PUR. But this is really kind of as deep as we get into data manipulation on the website. We're really much more about the dissemination and the preservation. And so I'm going to talk to you a little bit about our data publication process so you can get a sense for some of the functionality that we use and the staff behind the scenes that are necessary to make that work. And so from the author's perspective, they are really doing the bulk of the work in describing and packaging a data set for publication. So they will be selecting the data files that they want to publish. And we can also include, of course, like supporting documents, gallery images that we can show on our website to make it a little bit more enticing and inviting. We have a publication kind of workflow process that walks them through describing their data set. So they're providing us metadata that describes the authors, the subject matter. They're providing kind of keyword tags, et cetera. And we have really kind of easily understandable, human readable language that describes these different metadata fields to kind of ease them through the process. We provide them with a menu of licenses to choose from for sharing their data. They're all open access to some degree. We use a lot of Creative Commons licenses that allow for, really generous, broad reuse. And then we have some other more, slightly more restrictive, but still open access options for folks if they prefer those. Our authors can link their data sets to other related works. So if, for example, they're publishing a data set that mirrors a journal article, we can link to that article. And then once that kind of draft is complete, they're submitting that to our data curator, who they'll then work with on any necessary changes to either the files or the metadata before it's finalized and published. So that is what the author is providing to us. And then behind the scenes, kind of the process that the PUR system is doing is, in addition to the descriptive metadata provided by the author, PUR is adding some structural metadata, simple things like the date of submission, but also structural information about the publication that is kind of very behind the scenes and really useful for like archiving. The PUR system is also minting a digital object identifier through a partnership with DataCite. So that happens automatically when the user submits a draft. The PUR system is pulling together a publication page for that data set. So the PUR is plugging all that descriptive metadata into a web template to create a page, and then it is bundling all of these data files into what we in digital libraries call a dissemination information package. Basically a data bundle that can be linked to on the landing page for download. The system is also creating an archival information package, so a different copy of the data set that we will then submit to our archive network for safekeeping. And PUR is then, after the data is published, keeping track of the impact of the data, those views and downloads, automatically counting those so authors can demonstrate the impact of their scholarship. And we also have the staffing side of this, right? So our data curator at PUR is also working behind the scenes. He will be reviewing every data set that is submitted for publication. If you're familiar with the FAIR acronym of findable, accessible, interoperable, and reusable, this is what the descriptors we're aiming for in our data sets. So trying to make them as findable, accessible as possible. Our data curator will also consult with our subject liaison librarians. So for example, if we have an author from civil engineering submit a data set for publication and the data curator isn't really familiar with some of the subject matter, he'll consult with our civil engineering librarian and get their opinion as well. The system allows us to request changes from the user, so we can kind of annotate their descriptions to the data set and push it back to them to make changes and then resubmit for publication, so that whole process gets recorded. Once it is ready to go, we'll finalize the publication and work with the author during a 30-day, we have a 30-day grace period to make any necessary edits before we really finalize and then make an archival copy of that data set, which we found is just really practical because it's not uncommon that people find a typo or they forget to add an author or something that really doesn't change the content of the publication, but edits that need to be made to the description. Having that grace period is really helpful. And then our staff are also involved in some of the tracking. So a lot of the impact tracking is automatic, but we do like a more manual process of searching for citations. So we will a few times a year comb the internet for works that have cited our data sets, and we can link to those citations in our collections to kind of track that impact. And so that I know is kind of a lot of different steps that I've just flown through, and I don't expect you to anyone else to replicate this exact workflow, but what I wanted to kind of demonstrate was the interplay between the platform, the user, the staff behind the scenes, and the different kinds of things that we can automate, that we can really build into the system and customize to fit our specific needs.
Thank you. Sorry.
Oh, yeah, sorry. I was just going to add one last thing, is that I mentioned in passing kind of a lot of different partners. We also use a lot of metadata standards and specifications and those kinds of things. So this gives you a little bit of a sense of the different entities that are part of our kind of data landscape. So we're housed in the libraries. We work really closely with the research office on campus, with outside partners like HUBZero and MetaArchive, and then utilize a lot of kind of library standards and practices as well to help guide our work. So I hope that gives you kind of a sense of what we're doing over here at PUR.
No, it's fantastic. Thank you so much. And the library perspective is so important to those of us that may not be so familiar with that. And can't wait to show you this presentation to our library folks here at the University of Baltimore. I'm going to turn it over to Ale.
Yeah, thank you. Can you hear me?
Yep, you're good.
All right. Let me share my screen here. And so I'm going to tell you about NanoHub, and let me move Zoom out of the way for a second. And our goal in our platform is to accelerate innovation in simulation and data for our users and our developers. And I'm going to tell you a little bit about those two groups in a minute, but our users are researchers, instructors, and students who want to utilize simulation and data in their domains. And as Mike mentioned, NanoHub is the granddaddy of the HUBZero sites. We've been operating for about 20 years, and we have 2 million visitors every year and 22,000 simulation users. Those are the yellow dots that you see here in the map. Per year. So 25,000 individuals who come to the site, register, and run simulations using our technology. And so what are these folks doing? Well, they're running about 700 different apps and tools that are available on the site. Everything is, of course, through the cloud. These apps are contributed by the community. Some of them are contributed by us, but we run the platform and we engage with the community for developers to share their apps and make products that our users need. And as I mentioned, 22,000 annual users or so. And something that Mike mentioned, these folks run over 1 million simulations every year. And I'm going to tell you a little bit about what we're doing with all of these data, how we can leverage the data and the simulations that we provide. So So let me tell you a little bit what we're doing, and Joe mentioned this to some degree. What we're trying to do is accelerate innovation for end users, professors, students, researchers, and we want to put sophisticated simulation tools at their fingertips without them necessarily have to invest the time to become computational experts, both in the software and in the underlying hardware needs. Each one of these pictures that you see here on the left, I know NanoHub is in the focus on the field of nanotechnology and materials, and I know your background is different, but each of these tools that you see on the left are advanced science codes developed over many, many decades of PhD years. And each of them have their own input language, way of specifying things. And really, you can spend your PhD setting these things up. What we want to do is help our users, give access to these tools to our users who are domain experts, but not necessarily computational experts. And we want them to accelerate, their research. This is a network of papers published using NanoHub tools. There's many thousands of these papers. Actually, the network is of authors of those papers. And we also want to help our users be better instructors and better students, use these tools in education, both at the undergraduate level and at the graduate level. So we're really about democratizing access. I was interested to learn about this goal of the Neighborhood Indicators Alliance to democratize access to data. Well, NanoHub has those same goals, want to democratize access to the tools and to the data that they generate. And so the way we face these very sophisticated codes on the left, our users, is through apps or science workflows or machine data tools that are relatively easy to consume, okay? And I'm going to show you some examples. So these two represent two apps in NanoHub that are designed, supposed to be animations, and I don't know if the left one is running, but these are, they look like apps on your phone. With a few clicks of your mouse, you can be running a sophisticated molecular dynamics simulation and look at what atoms do when you try to deform a material. On the right, you're doing an electronic structure calculation using density functional theory. It's a quantum mechanical method that allows you to understand the electronic and mechanical properties of materials. And again, I know your background is not material science, but the bottom line is with a few clicks of a button, a student can actually have access to the tools that otherwise would require months of effort of an expert, not of students. So we've been, as I mentioned before, these type of tools have been available in NanoHub for over a decade, and they're used in the classroom and in research. Now, something that's a little newer in NanoHub is, of course, this explosion of interest in the field of data science. And across engineering and across the physical sciences, that's happening. And one of the challenges that we have been tackling is helping instructors and students learn about data science. So there's a need to teach our students data science. I personally believe that in 10 years, knowing data science and machine learning will be like today knowing how to use Excel. And so our students need to learn it. And the challenge is a lot of our professors don't know how to teach it because they haven't learned it themselves. So we are developing modules and making it very easy for professors to adopt these modules and introduce them in their own classrooms, or for students to learn them at their own pace. So let me give you an example of something that's kind of cool. These are a set of modules on data science for material science, where we teach students about data handling, once you know how to handle the data, how to model the data, and then how you can make decisions with that data. And in one of these modules, the students go to NanoHub. What you see here is an actual tool in NanoHub that any of you can run. It's a Jupyter notebook that you run on your notebook. There's no need to download any software to do anything. All you need is a web browser and an internet connection. And in this particular case, with a few lines of code, very, very few lines of code, very easy to read code, you can query a database and download 60,000 data points about materials properties, okay? And then we teach our students how to plot and visualize and filter that data. So this is extremely powerful, right? 10 years ago or 16 years ago when I joined Purdue, I couldn't have dreamt of having the students be able to have access to this amount of data from repositories and analyze it and learn how to make decisions with this type of data. But now we're teaching it at the undergraduate level. And so I guess the challenge is, as NanoHub, we have all these users, 20,000 users who run millions of simulations every year. They do it running these little apps. And at the same time, we have tools to analyze the data, these very cool data science tools where we can learn from data, we can make decisions based on data. So how do we find the synergies between all of these efforts? And one of the challenges that we've decided to tackle that I think the Neighborhood Indicators Alliance might want to consider is, okay, one thing is having access to the data, but then you're going to do something with the data. You're going to apply filters, and you're going to have a workflow of processing the data to come to some kind of decision or conclusion. Maybe you want to influence policy. That workflow also is data and should be treated as such. So one of the things we've been focusing on is making computing, the workflows that generate computational data or analyze computational data fair. And someone mentioned fair in the past. I think it was in the workshop, I think it was Sandi. And most people think that fair principles apply to just data, but they don't. Fair principles apply also to the workflows that generate data. So FAIR stands for findable, accessible, interoperable, and reusable. I'm not going to go into the details. There's a very nice publication that you see at the bottom that's a very nice, easy read that if you want to learn more, I would encourage you to read it. But the key thing is the data and the workflows to analyze this data should follow these broad principles. And we've been doing that. And let me give you an idea of the challenge in my field, which I think might be similar in your particular field. When we do research in material science, we use tools to make predictions about materials. And as always, as in all fields, research involves complex multi-step workflows. So again, I don't want to bore you with material science details, but let's say I want to calculate the melting temperature of an alloy that I'm interested in. Well, I have to build the alloy. I have to find a model in some repository to describe that alloy. And then I'm going to run a simulation using a code that was developed in some other institution. I'm going to post-process that simulation and analyze to see whether the simulation is converged, whether the simulation achieved the state that I wanted to achieve. And only after I'm done with all of these steps, I can make a decision, say the temperature is such and such. Well, when we write papers, we document these type of workflows in English. And English is not the right language to document reproducible scientific workflows. And so what happens is that these workflows that are complex to begin with are partially described in simulations. Important steps are ignored. There's ad hoc scripts involved. Students run these things. They do manual steps. They move things around that conspires against reproducibility. And the bottom line is these workflows end up being how you manage data. It ends up being not findable, accessible, interoperable, or reusable. And then that slows down progress because every time you want to do something, you have to do it from scratch because these workflows are not typically shared. So I'm going to spend my last 2 minutes telling you about a technology that we call SimTools that allow us to do that, to make workflows into fair workflows. And so if you think about what a workflow is, and this applies to any field, not just my own field, you have a bunch of inputs that you want to tweak. That includes your data, how you want to analyze it, maybe hyperparameters of your analysis, and you have outputs, the decision that you make or the results of your analysis. And what in SimTools we do is, okay, we ask the developers of these workflows to follow very simple steps to create a reproducible workflow. They have to declare the inputs and include the metadata that goes with those inputs, describe them, implement the entire workflow from input to output, including post-processing and pre-processing, and declare those outputs as well. And all of this is done in Jupyter notebooks, which are a very popular tool. And so what is interesting is the NanoHub SimTool library automatically does a lot of work. If you follow these steps, the SimTools are registered, the inputs and outputs are queryable, so you can ask, is there a workflow that will produce certain output, or what workflow would take these inputs and generate this type of output? As I mentioned that, they're queryable. The inputs are verified, so before running the workflow, the inputs need to be all correct and need to be within the ranges that the developer specifies. Otherwise, they don't run. And the outputs are checked before after execution, just to make sure that the workflow executed correctly. And every single one of the SimTools published have DOIs. They're indexed by Web of Science and Google Scholar. And the results, every time anyone from around the world runs a SimTool, the results are cached and are archived in a results database that's also queryable. So not only the workflow is fair, the data that these 22,000 users generate is automatically cached, automatically indexed, and automatically available for querying. So the users have no choice but to follow these principles. If you use a SimTool, when you run a SimTool, your data is automatically analyzed and stored and queryable. And as I mentioned, every single tool in NanoHub that we publish is a publication in itself, and it's indexed by Web of Science and Google Scholar. And this is very important because you give credit to the developers who are willing to share their work through NanoHub. And let me finish with one thing, and I know I'm over time. What this allows us to do is invert and reimagine how people use simulations and data. So the traditional approach is you have an idea, you go to a simulation, to your app, right? And you run, you set the inputs, you compute, and you get an output. And then you analyze the output. And of course, you have to go back and change the inputs and do things multiple times. And then you learn. Now, with this data, the data being available, the data being automatically indexed in a database, what you can do is you start by exploring the results by the community that have already been performed by those 22,000 users every year who come to the site. And so you explore the results and you learn, and you maybe realize, oh, there's some conditions where there's missing data, or no one has looked at this particular configuration. And then you compute only after you've learned what the community has already learned. And that really speeds up decision-making and innovation. The knowledge that gets generated, you generate your own knowledge while doing this, but at the same time, you contribute to the database, you contribute to the results database, and the next person can stand on your shoulders and take the next step. And I'll finish with that.
I'm so glad that you did
much.
mention this. This is fantastic, because even from a student perspective, this is what we want to do. Even if they're finding something, we want it to be this idea of standing on other people's shoulders, because we don't need to keep recreating the wheel, because a city like Baltimore will never benefit if everybody's just learning from first principles.
And here's a challenge that we found. If sharing your data is a post-process step, you never do it.
Right,
and
right.
Even
Yes,
if you
that
put a
is true.
gun on people's head, they say you have to share the data, NSF says so. They don't do it, or they're going to share it in a bad way that no one really can learn from. And so it has to be part of the workflow. It has to be that you don't have a choice. It can't be that the students collect data, put them in their laptop. You know, in my field, we do research, we go to the lab. These are very expensive simulation, very expensive experiments, right? They take a lot of time in material science. And the data ends up in an Excel sheet. And then a fraction of the data gets published. The majority of the data dies in the Excel sheet in the students' laptops. And it never sees the light of day. And that's just a waste of resources.
We've also found that people are nervous to share their data. There's like this idea of data shaming.
Yeah,
they feel like they're gonna be judged on what their data is gonna look like. We have just a couple of minutes. And so what I thought I would do, and instead of doing a Q&A, I wanted to give an opportunity to Michael Zentner and Sandi and Joseph to maybe reflect on what you heard, maybe advice to others that are thinking about doing this, or what the state of the art will be in a couple of years on this idea. Joseph, you want to 30 seconds on what you thought?
I don't know. The only advice I would give is, I think whatever you do, you've got to be pretty passionate about it. As you can see, all the speakers are quite passionate, because this is definitely above and beyond what you're expected to do. And that'll get draining after a while, because running something like this is a lot of work. And so got to be passionate.
Good luck finding that funding, and I think we're all in the same boat on that one. Sandi or Michael Zentner?
Yeah, I guess I would add, in addition to passion, partners. So PUR only works because we have strong partnerships within libraries, with other university offices, and we have someone on our staff in my role who's working on education and outreach to keep those partnerships alive. So that's definitely key for us.
And Ale, any concluding remarks?
Yeah, no, I think passion is important, partners is important, but I think you have to have a mechanism that it's automatic. To me, that's the only solution.
And you think that HUBZero is providing that?
That's exactly right. And when you analyze the data, you share your analysis, right? You share your conclusions. People can look at how you made the decisions, what data you analyzed, and can look and read what analysis you did and maybe disagree with it. And the other thing is education of the public. and education of our students so that they're good stewards of data, but also they know what to, you can put the data up, right? If people don't have the ability to query the data, to use modern tools to understand the data, then your impact is really diminished. There's just a few, high priesthood cast that can analyze the data and tell us what it means. That's not what we want, I think.
Well, thank you all so much. This will be a recording that's available for others to see. And I appreciate all of your time and thoughts and great information for all of us here in Baltimore and to all of our students. Thanks everybody for being here.